Okay. Can't see. It's a little high. Hello. Well, look at you guys. You're all here. Yay. We have a big group. I'm going to share this screen because I don't know what you guys can see. Hi.
Hello?
Okay. Can you see everybody?
Do I need to turn my camera on?
You guys don't have to, but if you want to, say hi. Yesterday, nobody would. I understand. I'll turn mine off here in a second. I just wanted to say hi to everybody. How are you guys doing? Everybody okay?
Yeah.
I'll bring up the chat. Yeah, don't you love that background? Isn't it awesome? I had to do a lot of searching. I don't have a green screen though, so it's a little flaky. Good morning. I'm glad to see everybody's here. You can tell I don't have the best camera set up. And you know, I always just share my screen anyways. So that's what I'm gonna do. Let me move this back out of the way. And I wanted to, first thing, take a look at just a special presentation where we could talk about everything here, hopefully. And then if you guys have any questions or worries or anything like that, we can go over those first because lots of changes, lots of things going on. It's super stressful. I don't know how you guys are doing, but I think it's really stressful seeing all the terrible things going on. And so I'm so glad you are here. It's nice to have normal stuff, isn't it? So OTC has been working like crazy, and you guys have probably seen all sorts of different emails. But right now, some of the decisions that are in the process or have been made are that nobody's grade would ever go below what it was at midterm. So the way I'm looking at that is that your grade can see improvement only. We want to focus on the learning aspect instead of the grade, which is great. That's what I think we should always be doing. Then the other thing that's in the works is a no pass option. And this is an option where they're going to allow students to mark a class as pass or no pass. So if you get a 60% or above, it would be a pass. Now, normally, when something like this is offered, like when I went to college, you could always do pass fail. You only want to do that for a class that's like not super important to your major, like, you know, Missouri State, I did PE a lot. So different things like that. So, but that option is going to be available to you. So that's something to just be looking for, maybe for some other class or whatever. Next, OTC is going to have one computer lab open at each location. So in Springfield, it's going to be in that ITC building. I don't know that it will have our software installed. Right now, things are kind of up in the air, and I think they're more focusing on just trying to get basic software available. But they do have Wi-Fi open in the parking lots, and they've been working on boosting that so that the signal is a little stronger. And Wi-Fi is available in all the parking lots at the Springfield Greene County libraries. Because you would be using the Wi-Fi for school, that is an allowed activity as far as leaving home. So you can sit in the parking lot and use Wi-Fi. Not exactly the best opportunity, but at least it's something. Then lastly, if you don't really have a computer, if you have more of a thin client, you know, like a tablet or a Chromebook or something like that, Neil's been working on getting you a remote client available. So this link, and I'll post this presentation, but this link will take you to a facility that lets you log into OTC using just an internet connection, and then you can run several of the OTC software applications on this remote desktop. So it's super handy, it's very fast, it works really good, and he does have Python installed. So that's something, if you're taking a look at it and you're not sure where to go or what to do, just let me know and we'll get you fixed up there with that. So some resources available. I think a lot of you are in pretty good shape computer-wise, which is great. So if you had watched Discord over our breakish thing, there was a little bit of discussion about what software we need. We need the Zoom client and Discord, and of course both of those can be run cloud-based if you don't want to install anything on your machine. It'll be a little bit slower, but you can run them that way. Python should be installed, and you can get any version of Python that's over version 3, you know, 3.6 or whatever, and that should work fine, any version. Now, can anybody think of any others? Because I know there can be some obscure software that we use without even thinking about it.
What about Raptor?
I will make sure to not assign any assignments that use Raptor. So you can install it if you want to do some working with it.
Visio.
Yeah, we'll just make sure to not have any flow charting assignments for the rest of the semester. So you guys just have to do everything with me. Do I? I didn't hear that one. Well, hopefully that'll be all. We'll see. So our plan, we should not be needing to use Visio, Isaiah. We'll try to stay away from all that flow charting stuff. If I forget, you guys can call me on it, and we will fix it. So we're going to meet via Zoom at a regular time like this because you guys had signed up for a seated class, so I don't want to leave you just out there alone online. But if you can't meet at the regular time because things have changed or it's just not convenient for you, the Zoom session will be recorded and posted to YouTube. Now, no matter how you watch it, I want you to log your attendance. So let me show you that. In Discord, in our 120 class, this link right here on Office is just a real quick form. All it has is for you to put in the date, and I just want you to submit that you were here. Right now, attendance is all kind of up in the air, and they were saying that it wasn't something we were going to have to worry about, and then last night they said that it is something we're going to have to worry about. So let's just go ahead and make sure you get that attendance logged, that you either watched that session or were part of it. Now, I think you'll benefit by being part of our live Zoom session because if you have any questions or trouble, you'll be able to ask. But I do think that I understand if you can't make it. So we'll just try to make it to where it works for everybody. All right, so that's our getting back to class stuff. Questions? Stuff I left out?
Just need to log my attendance.
Do I?
Need to log my attendance if I can get out of this. There we go.
Did it let you out? I'll try to post that URL with the YouTube video in the comments so that you don't have to go searching for it if you're watching that Zoom session later. But you know how sometimes those best intentions go, so I'll try to do that. Okay, so we're in pretty good shape, I think. We do computer stuff. Whoops, got some code up here, don't I? We do computer stuff, so we should be adaptable. I'm looking at Canvas now, and I want to kind of look at where we were, where we left off before our break. It's like I want to call it spring break. Well, it was spring break, wasn't it? So before our break, we had our Unit 2 exam, and I looked at the statistics for that to see if we should review, and it looks really good. Like everybody did a really good job. I think the problem areas are in some of those written responses, and I hope I found all those to give everybody the points. Let me know if I missed some of yours, but I don't think we need to review through that. If it's something that you want to review, do take a look at yours, but overall, just excellent job, excellent, excellent. And we're ready to start looping or repetition. So some people I know have already finished their review questions, and some people have turned in our Loops with Turtle assignment. Our big assignment for Python-wise that's due Thursday will be this sum of squares program. So the way this program should work is if the user types in a value of 4, then the output should be something like 4, I don't know, 4 times 4 squared (3 squared) and so we would be using the Python math library here to use the power function. So I don't want to just multiply 4 times 4. We want to use that math library. Are you getting a whistling? Is somebody got their mic on? We might be getting some feedback because I'm not hearing it. Is everybody hearing the whistling? If you've got your mic on, go ahead and mute it because sometimes that makes some weird noises. Is it better, Isaiah? Can you tell? Okay, good. We got it. All right, so this is what my output might look like. That would just be one, right? For this sum of squares program. And then my sum would be 16 plus 9 plus 4 plus 1. So what's that going to be? 29, 30? So that sum would be dependent on what the input number was. So the sum of squares program, it can be kind of confusing in looking at the description. We're going to start with a number, and we're going to square that number and square all the numbers less than that to come up with a sum. And you should know how to do that by the time we're done. So we'll make sure. So let's look at how we do that kind of stuff with Python with repetition statements. I'm going to grab this PowerPoint, the repetition statement one, and I think I already have it, so I don't have to download it. See if I can get it started. I'll need to swap that, huh? So this is chapter 5 in our Prelude to Programming book. And of course, you guys already did just a little bit in the Python book because they threw some looping constructs at you a little bit early. When we started with if statements and selection statements, I told you the important thing is the condition. The condition is the part after our if keyword, right? If A equals B. And our condition always results in a true or a false, never anything else. So we want to think about what to do if we want to repeat some code. So a good example would be thinking about an assembly line robot. I might have a robot that's looking, that's picking up a block and looking at the block. If the block is hollow, he places it in one pile. If it's not hollow, he places it in another. Then he picks up the next block and looks at it and repeats the process. That process would be a loop, a looping construct. We want him to continue examining all of those blocks until there are no more blocks, right? That's when we would be done. So when we're creating a looping construct like that, we have to specify this is the code that should be executed over and over based on a certain condition or until a certain condition has been met. So let's think about it with a flow chart. Here we have a flow chart. We start, we get some data. Based on that data, we have a decision. If the response to our decision is a no, we're going to do some sort of process. Fix some things, check some things. Does it look prettier? And then come back and check again. Is everything good now? No. Okay, well, I'm going to do some more fixing and I'll keep trying. When we finally get a yes response, we would leave our looping construct and continue on with our flow chart. Now, looking at the flow chart, notice this looping construct. We cannot usually see one because we have a line with an arrow that's going backwards, right? And usually our arrow is going to go into a decision diamond of some sort because we want to repeat this process until we've met some sort of criteria. So when we're creating our condition for our loop, we're going to do the exact same kind of thing as we do to create a condition for our if statement. Our condition is going to result in a true or a false. We're going to use the relational operators, less than or equal to, greater than or equal to, is equal to, and is not equal to. So we're going to use the same kind of conditions. Our condition still has to have two sides. We can use variables. We can use values that we've got in double quotes or numbers. Now, some things when we're working with looping constructs that we need to be aware of. One term is an iteration, and an iteration is one execution of the loop body. So when my robot picks up a block, he's starting a new iteration. Actually, he might start it when he checks to see if there are more blocks. But either way, the iteration is going to be the whole process, checking the block, putting it in the right spot, and then being ready to start again. That's an iteration. The loop body is the code that's going to be executed over and over if the loop is true. And then a bad thing is an infinite loop. And an infinite loop is a loop that never ends. We never satisfy its criteria, and that can be bad. Okay, as we're creating loops, structures in our code, we have some different types or different ways of formatting our loop structure. Here is a visual of a pretest loop. And a pretest loop is where we check a condition before we execute the loop body. So in this example, we input a number, we check to see if that's valid input. If it's not, we're going to ask for a number to be input again, and then we're going to check, is it valid? No, input another. When it's finally valid, then we'll leave our loop to do whatever work we need to. So in this example, this area right here is our loop body. Right? Though that's the code we want to execute in our looping construct. Now, when I'm working with a pretest loop and writing the code or writing the pseudocode, I'm usually going to be using the while keyword. So the while keyword gives me syntax that's exactly the same as an if statement, except that I use the keyword while instead of the keyword if. So when I have a while statement, I'm going to have the keyword while followed by the condition. Then indented, I'm going to have the loop body, the code that I want executed while that condition is true. Then I'm going to have an end while indicator to show that that's the end of my loop body code. So if we look at this one, the while and the end while are required in our pseudocode because otherwise we wouldn't know when this thing ends. Indenting might help, but they like the end while. So that's a good loop. All right. That's a pretest again because we're testing our condition before we execute our loop body. So if our test condition was never satisfied, we would never execute our loop body. Now, what about a post-test loop? A post-test loop is where we check our condition after we've performed the loop body. So the flowchart would look just a little different, but not much. We would input a number, check to see if it's valid input. If not, we would just input a number again. Now you can kind of see that this flowchart is like a little bit more logical, isn't it? Because this post-test loop works really good with this situation where we're validating our user input because we always want them to input a number before we do it. So it kind of is logical for us to check it after that activity has been done, where in our previous one, if you notice, we're kind of a little bit less logical. So my post test, we're going to input a number, check it. If we need to execute that loop body again, to input another number. And here's some pseudocode. In Python, we don't have this construct. We cannot do a post-test loop. So we can use this code in a lot of other programming languages, but Python has decided that it's not necessary. And really, as we use Python, we'll see it's not. But we could have this code in a couple of different ways. So one syntax we might run into would be a keyword repeat. And then at the end of our loop, we would have until some condition. So in this case, if we were looking at our robot, we would have repeat, check the block and put it in a pile until we are out of blocks. And that would be pretty logical. Another code syntax that we might see for the post-test loop is a do while. So we could just different programming languages, and they're all fine in our pseudocode. But a do while starts with the keyword do, and then has the loop body, and then ends with the keyword while with the condition. So very similar to what we were just looking at. Do this loop body while this condition is valid. Now we can have nested loops, so I could have a while loop within a while loop within a while loop. My example here is trying to park. So when we come to OTC, we don't do it right now, but used to, when you go to OTC, you would start this while loop trying to park. And then you might have inner while loops while you check specific parking lots. Like maybe you're checking the Norman K. Myers parking lot, and if you find a parking spot, you're going to set these flags, some Booleans, to let yourself know that you found one. Otherwise, you're going to keep looking. And then in our while condition, we might check these flags. So we could have a nested loop like that because we have that kind of logic happen all the time. So how's everybody? Do you have Python? Do you want to try some Python code with some while loops? Yep. Let me find my...
Sounds good to me.
Yay. Okay, I'm looking at the participant thing in Zoom, and it does have this cute little yes and no button, but I don't know where those are on you guys' end. But I guess we'll try Python, and if somebody doesn't have it installed, they can look at the Zoom session later and make sure that they got everything working, because then they'll be able to test it. So let's try it and at least make sure everything is working for everybody. Find my Python. Now it's showing me idle here. There it is. So my computer, I actually have Python 3.6 installed, but like I said, I don't think that should give you any trouble if you have a little bit different version. But I'll go ahead and run idle. Try to close all of this other stuff here. Hide that Java logo, huh? Okay, so I've got idle finally open. It's been a little while. Remember, we have to tell idle to create a file. So I want to create a new file. And then let's see what we want to do for our very first one. I think I'm going to save this. And I'm going to use my OneDrive. Hopefully your OneDrive is all working.
How do we sync our OTC OneDrive to our computer?
Oh, okay, let's get that fixed. What you can do in your system tray, you should have your OneDrive icon. Let me find my personal one. Let's see. I remember it was really easy. I didn't have to do anything. Let's see if there's OneDrive on our desktop here that we can. Let me cancel that. Now, all it's doing is starting this cloud-based, or the little cloud icon here in the taskbar. So I'll find information from OTC. I know it was super easy. I can't remember. There it is. On your OneDrive icon in your system tray, click on it and choose More and go to Settings. On your settings, go to Account and click Add an Account. And then you should be able to add your OTC account. Does that work? Oh yeah, and Chelsea mentioned you can go to office.com and download OneDrive if you don't have it. But OneDrive comes with Windows 10, so I don't think you should have to download it, but you can on office.com if you're not finding it somewhere. I'm going to give you a second to kind of look at that and see if everybody can get it going, because it'll be so helpful if you can get to your OTC OneDrive. Oh yeah, and Isaiah mentions it comes with Office 360 too, so you probably already have it installed. I'm going to go ahead and save then, and any of this stuff that you're having trouble with, just let me know and we can work together and share your screen and get everything fixed, hopefully. All right, so again, I'm going to go to my OneDrive and my 120 folder. And of course, I have a spring 20. And I want to save this as a chapter 4, chapter 5. Look at us. So chapter 5, in this first one, I'm just going to name it Basic While Loop. I want you to be able to find that in your sample code files. So let's see. Try to remember what we do here. I want some comments. We increase size here a little bit. It's a little better. And our purpose here is just going to be explore while loop syntax. Whoops, I only got 2 there. 3, okay. So one thing that we can do right off the bat is try a bad thing. So I'm going to set up a while loop, and my condition is just going to be true. So I'm going to say while true, which is a forever condition. I want to print the word hello. Now, this would be an infinite loop. So let's run it. Ooh, let's save this first. Sorry if you had already started and hadn't. You might have to type again. Whenever we're working with looping constructs like this, we can create an infinite loop by accident, and we can lose some code if we haven't saved. So good to save often. Oh, it's mad at me. It does not like true. And I should have known that, right? Because it didn't color code it. So I have to make it an uppercase T for true to be meaningful to Python. So I'm going to run that again. And there's my infinite loop. So we can let this run forever if we wanted to. It'll eventually eat up a lot of resources on our machine. If we want to stop it, there are some different things that we could do. But one real handy keystroke to remember is Control-C for cancel. So if I do Control-C, that'll end that execution and kill that loop. Okay, so did you create an infinite loop? Did it work? You see it? Mean old thing. Now, how could I keep this from being an infinite loop, but let me do some things? Well, I can use a flag. And a flag is just a Boolean value or variable that we use to indicate a true or false condition. So now in my loop, I could say while valid is that loop going to execute? Let's try it.
Control-C, I am spamming Control-C, I am spamming Control-C.
Is it not doing it? Not letting you out? Make sure to click on your output screen so that the Control-C is being read by your shell. let's see what else we can do. Control F6. If you can't get it killed, you might have to use Task Manager.
I have to close the output window.
You got a persistent one, huh? Sometimes when we get a loop like that, we call that really tightly bound. It's got a hold of the CPU, the processor, and it's just not letting anything else into the processor to execute, including the cancel command. So we can get an infinite loop that's so tightly bound to the processor that way that we can really cause some trouble. That's how some viruses are made, isn't it? Some of the ones that are a little bit destructive. RJ says he just hit the X up in the top corner. Well, that's not a very elegant way, but it works. So don't forget about Control C, because that'll work if you're, no matter what environment you're in. Now I'm going to try to run this right now. I've switched it to use this flag, just this Boolean variable, and I'm going to set my Boolean variable to false to start. And now if I run, I'm not going to get any output because my loop will never execute because my condition wasn't met. Now if I change my valid flag to true, what's going to happen? It's going to do that infinite loop again, isn't it? Yep, there it goes. So it's going to stay true. So whether I'm using just a basic true Boolean value or a flag, same result. I'm going to Control C. Kill that thing. So we can make our infinite loops that can be super destructive. We can really cause some trouble in the system. So we've got to be sure what we're doing. So we saw in the presentations that one thing that we might want to use a loop for is to validate user input. So that would be a good thing for us to try with this while loop. I have my Python quick reference in Word. See if that's on my OneDrive. Make sure I have it before I say that. I think I do, but it might be at OTC. It's been a while since we updated it. I'm going to go ahead and add this while syntax. And then I'll drop this file onto Discord in case yours is at OTC and you can't get to it. So in our while statement, we have the while keyword followed by our condition, followed by the colon. And of course, I just put that in really fast and didn't even mention it because we're so used to it. Now our while statement. And the code for the loop body is indented. Let me save this and send it to you. And then we'll be able to update it all together. Okay, so there's that Word document. And I know it's a lot more useful to us at the beginning when we're just starting out with Python. But after a few weeks of not being able to use it very often, maybe it'll be something you want to look at again. So in the quick reference, I said that the things that are in the loop have to be indented. Let's do some work with this one before we start trying to validate user input, try some other things. I think I want to set up a counter to count how many times we run our loop. So then every time we print out hello, I want to add to our counter. Now that's still within my loop body. And then if, I'm going to say if my counter gets to greater than, how about 100? Then I want to set our valid flag to false. And that should stop our loop. So let's try it. So I got about 100. I could make sure, let's print that. Let's print out how many times we executed our loop after our loop is done. So I'm going to outdent so that this code is outside of the loop. And I think I'm just going to print out, we looped, and then we're going to have to convert our count to a string. So I want to print, we looped however many times our count is set to now times. We think that that should be 100. Let's check. Oh, there it is. I need a space. It's 101. Put a space. Why would it be 101? I said if it's greater than 100, to change it, 100 is not greater than 100, is it? So we have to be super careful. So that gives us that 101. Now, we could do the same thing. Let's duplicate it. What if we said, we're going to set our count back to 0, and we got rid of that flag. A lot of times beginning programmers like to use those Boolean values because that's what a lot of samples have, and that's great. And sometimes we will see that that's the best way to handle our logic. But in this example, it seems kind of convoluted, right? Why don't we just use our count? What if we say while count less than or equal to 100, and then we print out hello, and add to our count. And then outside of our loop, we print that we looped this many times. So we should get the same exact result, right? So in our first example, we used a Boolean flag. And in our second example, we're just using a counter to control our loop. So it's a count controlled loop. Let's run and make sure both of those work. So if I scroll back, I should see all my hellos with only one exclamation point that executed 101 times. And then all of my hellos with 2 exclamation points. Okay, so a few things. I'm going to put this out to the side. It is considered a state loop because our flag is indicating the state of things. So our flag here indicates whether something is valid. So this would be a flag controlled loop or a state loop. And this one down here would be a counter controlled loop. You guys are just so quiet. It's just like being in class. Okay, has everybody got that one okay? I think we're good with that. Let's change it up a little bit to be an input so that we can ask for input from our user. So here in our beginnings, we don't have any modules here, so it's getting a little messy. But I could ask for input. So let's create a variable called number. And I think I want that to be an integer. And I'm going to use the input function to ask the user for a number. Let's say, please enter a number greater than 10. I just think this is going to get all messed up, and I don't want to do it this way because it's just going to be too ugly. So let's just delete that. Let's save this file, and let's open a new one. I think I want to save this and close it, and then I want a new file. That one was just going to get too ugly and too hard to follow. So let's save a new one. Go to my OTC OneDrive and save this. So for this one, this will be chapter 5. Hi, Josh. Yes, a flag is just a term to describe a Boolean variable that's controlling some sort of logic like that. So that's the only thing that we would indicate a flag for, like a flag. It comes from back in the naval days, working at sea. The seamen would wave flags at each other to indicate the status of things, like, you know, if the sea was too choppy, or I don't know, you know, if the captain was mad or something. So they had these flags, and they would use the flags to indicate statuses. So they had kind of a code. You know, if the flags were crossed over, it would mean one thing. And those are called semaphores. And so those flags are where this term came from. So it's just a Boolean variable that's going to indicate some sort of status. So Too much history there, huh? All right, so let's name this one something different. We're gonna say that this is gonna be a while validate input, because we're gonna make sure that our user gave us good input. And we know that we're responsible for validating input. So even if we give the best instructions in the world and there's no reason that anybody should type anything in wrong, we still have to validate and make sure that they didn't. So that's just one of our jobs. So the purpose of this one is to prompt user for valid input. So this first example is going to come out a lot like that first flow chart. Let's set our variable so our flag is set to false. And we're going to go ahead and prompt that user for input. So please enter a number. Let's do a range between 4 and 7. Now in our while loop, we're going to say while not valid. And we're not valid here to start, right? Because we've set our valid variable to false. So as long as things are not marked valid, we're going to check that input. We just got it. So we can say if our number is greater than or equal to 4 and our number is less than or equal to 7, it's valid, right? They did it right. Now, if it's not, we need to prompt for input again. So we're going to use this same line of code, which you see if we had in a function or a subprogram, we could call that subprogram again. Now, at the end, I'm going to print the valid number is their number. Everybody got it? Let's try running this. We should see our prompt. It doesn't like that, does it? So how can I do that? What would be the best way? I guess we have to use the word not. Too many languages. Let's try that. Okay, so now I'm getting the prompt. Please enter a number between 4 and 7. So I'm going to enter a number outside of that range and make sure that I'm getting prompted again. And then finally, when I enter a valid number, it ends the loop and we get out our message about the valid number. Is everybody's work okay? Working. So beautiful. But it does seem a little clunky, doesn't it? Let's try a different approach. And we could use the input from our user. Now, for this approach, I'm going to start out with our number being 0. We're going to control it. And then in my while loop, I'm going to say while our number is less than 4, or our number is greater than 7, I'm going to kind of make that the opposite condition that I want to prompt for input. I'll put my space there. It was looking so ugly. Now, if I do things this way, I shouldn't need any other code in my while body. I'll backspace then and put my final print statement. And let's try to run that. Now, my first approach, we're using our flag. Our second approach, we're just letting the user's input control the loop. So I'll go ahead and enter a valid number for this first one. And now for my second one, I want to do some testing. I am staying stuck in my loop as long as my input is invalid. And when I type my valid input, I should see my final message. Yay. Everybody's work okay?
Mm-hmm.
Let me get this up here. Now, what could I do if I wanted to do some sort of loop using that variable? So let's say in this example, I want to output something about that number and all of the numbers that are less than that number. So I want to start out with a loop. So while I've got this number, while number, I'm going to need another variable. I think I'm going to need like a counter to keep track of what's going on. So let me set up a counter.
Are you sure you don't just want to use a number as a counter?
Well, number was my user input, so I don't want to change it, right? Because we've got, so that's going to be, if you think about the sum of squares program that's due Thursday, number would be like the user input for the number they wanted to start summing on.
My brain would usually just be like, well, just count down with number until you hit 0.
We could do that, so let's try it. I'll just comment this out. I think you're right, that should work. While number is greater than 0, we would want to print what our number is. And then because we're decreasing, we're going to subtract. Now, when we run this loop, we should end up just outputting this line, number is, for whatever number we've entered, and then we should see number is for every number less than that number that's greater than 0. Let's run it. Set it. Weird. Okay, so for our first input, I'm just going to do 4. For our second, I'm going to do 5 because this is the one that's going to control our output loop. And so there in our output loop, we started with the number, and then we're decrementing that and printing out all of the numbers less than our user input. Now, if we wanted to add more to that print, let's add a little bit more. And let's say if we doubled our number, it would be number plus number that we would print out. Let's try it. There we go. So now we've got our original number that the user input and another number that's dependent upon it. So this is a great way to handle it. Now, when Isaiah mentioned using our number variable, you know, I was kind of reluctant, right? Because that is our user input. So it is kind of destructive, because once we got done with this loop, we wouldn't know what their input had been. And in this case, that's okay, because we don't need that anymore. So we're all right. But in some cases that might not. We might need to keep that input. And if so, we could just really easily set up another variable and set it to hold that number value so that we could keep track of it. So that should keep it for us. So that's some good examples for you, I think, and should give you enough to work on that sum of squares, some of the other assignments. Next time, we'll look at for loops, and for loops in Python are actually really, really powerful. So even a little bit more powerful than our while loops. So you'll really like them. Any questions? Everybody good? We'll save this and I'll post it to Discord. So let me know if you're having any trouble with anything, if you're having trouble with resources, computer-wise, technology-wise, or the internet. If you're having trouble with anything else, you know, there's just lots going on right now. If you're food insecure, if there's anything else like that going on that we can maybe get you some assistance with, let me know. I don't know that we can get you help, but we can sure try, because that is, you know, OTC's main mission is to make sure that you have what you need to be successful. So I think we're good. Now, Isaiah says, I assume we should go to study groups. Now I'm going to leave that up to you, and I'm going to have to let you guys create your own Discord study groups. I'll work a little bit on the Zoom meeting rooms and see if we want to try that. But for today, you can see if you can message each other via Discord or any other facility that you like, and kind of review what we did and talk about it if you have any questions. I went over the while loops kind of quickly, so I definitely want you to take a look at it and take some extra time. Use that website where you can step through the code and kind of watch that loop execute, because that's a really good way to learn what's going on there too. Yeah, use Discord, anything that you can do to help yourself, help your group. get everybody on the same page so that everybody's comfortable with this. I'm super concerned because looping structures can be difficult for people to get a handle on, and then we have all of this other stuff going on too. So do practice, practice, practice as much as you can, and that'll help. So let me know if you have any questions. Everybody good? I'm going to go ahead and end the session unless anybody has any questions. And I will see you Thursday. Thanks, guys.